Hi everyone, welcome to today's homework help video. Let's go ahead and get started. For this one we have the sum of 5 and 4, which is being subtracted from the product of 3 and 3. And we want to figure out what the difference is going to be. So first things first, you're going to resolve 5 plus 4 and get your sum. And then you're going to resolve 3 and 3 or evaluate and get your product. And whatever you get from those two, you're going to then subtract it, and that's going to give you the difference between these two expressions. Moving on to number 2, if the minuend is 27 and the difference is 9, then what do we know about the subtrahend? So this is very similar to the problems we worked on yesterday. The only thing now is to figure out the value of the subtrahend. And you'll notice that based on the equations that we worked with yesterday, since the subtrahend is the unknown value, we can just swap it with the difference and then evaluate the subtraction on the left to solve for the subtrahend value. So for number 3, what is the name for positive number for numbers that are greater than 0? And I just gave you guys the answer. So numbers greater than 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could say that those are counting numbers, but in a way that's more related to what we were working on today, realize that any value that's greater than 0 is a positive value. So then any number that's greater than 0 is a positive number. For 4a through d, we want to evaluate these expressions when n equals 6 and m equals 24. So all that there is to do is to rewrite the expressions, but instead, and keep the operation, but instead of m, we replace it with the value that is given to us, which is 24. Instead of n, we replace it with the value given to us, which is 6. And here, this one's actually in the reverse order, so we have 6 minus 24. So you'll notice, since we use the same values and we use the same operation, that a and b are going to be opposites. One of them is going to be a positive answer, and the other one's going to be a negative answer. As we went over in class, anytime the minuend is bigger than the subtrahend, as is the case here, your answer is going to be positive. But if the subtrahend is bigger than the minuend, your answer is going to be negative. And keep in mind that we're just going to subtract these like we would normally subtract them. The larger number goes on top no matter what. Later on, we're going to get into the fact that it's called the larger absolute value goes on top. And then you already have your sign, so once you evaluate, you just keep that same sign that you had from earlier. Another thing to keep in mind here is that fraction represents division, and that when you have two variables next to each other or a number next to the variable, it represents multiplication. For number 5, use digits and other symbols to write the product of 5 and 2, which we have here, 5 times 2, is greater than the sum of 5 and 2. So then we have our symbols of comparison, greater than, less than, or equal to. And remember that for greater than, it points to the right, and for less than, it points to the left, and then the equal sign is just an equal sign. So make sure you pick the appropriate one when comparing the product of 5 and 2, which is 10, and the sum of 5 and 2, which is 7. For number 6, we want to rewrite these in order from least to greatest. So as a reminder, the further you get away from 0, the less value you have. So in this instance, on the number line, -2 is actually the furthest number from 0, and then -1 would be next. So from there, it's just a matter of figuring out which numbers are left that has the second greatest value and then the greatest value. For number 7, what we're being asked to do, if we know the divisor, let's say the divisor is here, and we know the quotient, how can we find the dividend? So I can rewrite this as a fraction problem. So where the dividend, the number on the inside of the box, goes in the numerator. That's why I represent it with E for dividend. The divisor, the number which is outside the box, goes in the denominator. So that's O for divisor. And the dividend divided by the divisor equals the quotient. So I'll give you an example here. We have E, the dividend, divided by 5, the divisor, which equals 6, which is the quotient. So then to find out what the dividend is, you simply multiply the divisor and the quotient. For number 8, we're being asked to use a number line to show 2 take away 3. So we start with 2. And then since we're taking away, we know we're going to move to the left. And we're going to move to the left 3 times. So 1, 2, 3. And we arrive at the value of 2 subtracting 3. For number 9, we're being asked to solve for x. 12x equals 12. So we have to identify our operation first, which we know is multiplication. Anytime a number is next to a variable, it's just multiplication. Identify the inverse operation, which we know is division. And then you're going to divide both sides by the number given, which is 12. And then you simplify. For number 10, we're being asked to solve for n. I'm going to use the commutative property to rearrange these. So we have n plus 8 plus 4 plus 6. And that's going to be equal to 30. The next step is actually going to be to combine the numerical terms. So we're going to have 8 plus 4 plus 6. And whatever that sum is, we're going to have n plus that sum equal to 30. The final step would just be to realize that we're adding, so we have to use the inverse operation, which is subtraction from both sides by the sum of 8, 4, and 6, and that will give you your n value. For number 11, we have z minus 123 equals 654. So again, since the minuend is the variable, we just have to use our inverse operations. So instead of subtracting, we're going to add the value that's being subtracted to both sides. In this instance, that is 123. As we mentioned yesterday, and as you can see a little bit more now that we've talked about opposites and integers, negative 123, which is basically what that is, and positive 123 are opposites. So they cancel each other out, leaving you with just the z variable equivalent to the value of 654 plus 123. Now 12 is a little bit trickier. We have 1000 minus m equals 101. So what we want to do here is realize that the subtrahend is the variable, which means that all we need to do is swap the values. And again, we only do this when the subtrahend is the variable. So we have 1000 minus 101 equals m. And then from there, all you have to do is simplify by subtracting 1000 and 101 to find the m value. For 13, we have p plus $1.45 equals $4.95. Right off the bat, I'm going to tell you that your answer should have a dollar sign in it. So again, we identify our operation. We have addition. The opposite of addition is subtraction. So we use the inverse operation to subtract $1.45 from each side. Now, it's important to keep in mind that when we're dealing with decimal operations, specifically adding and subtracting decimals, we want to, just like in Hercules, I'm going to keep saying that all year, that our planets align, we draw our decimal where it needs to be, and then we complete the operation as necessary. For 14, we have 32 multiplied by k equals 224. So, again, we recognize that our operation is multiplication, and that the inverse of multiplication is division. So then we just divide by the coefficient, which is the number next to the variable. That's 32. 32 divided by 32 is 1. 1 times k is just k. So that goes away. And that just rhymed. I am only a poet half the time. So then 224 divided by 32. Here we have r divided by 8, that's not a g, I promise, equals 24. So now to solve for r, since our variable is in the numerator, there's no need to swap anything out. We just use our inverse operation, which in this case is division, and we multiply both sides by the denominator, which is 8. That will cancel out, leaving you with r equivalent to the value of 24 and 8, or the product rather. For 16, we're asked to find the first and second steps. Notice that in part A, we just changed the order of what was inside the parentheses. So you want the property that changes the order, right? And then in B, we kept it in the same order, 4, 9, and n, but the difference is that now the parentheses have moved. So you want the operation, or the property of operation, where the brackets or the parentheses move. Yes, that spells bracket. All right, 17, replace each circle with the proper comparison symbol. So again, we have greater than, less than, or equal to. the first thing I would advise is to evaluate where necessary, right? So 3 times 4 we know is 12, and 2 times 6 is also 12, right? 3 subtract 5 we know is going to be a negative answer, and we know 5 minus 3 is going to be a positive answer. Negative 3 and negative 2, it's just a matter of comparing them. As a reminder, the bigger a negative number, the smaller value it actually has. And then for D, x, y, and multiplied by yx. So let me give you guys an example there. Let's say we had 3 times 2 and then 2 times 3, right? Both numbers are being multiplied. The only thing we did was change the order. But as we know with the commutative property, if we change the order in the multiplication problem, our product will still be the same. So make sure you use the appropriate symbols when comparing those. 18 gives us $100 minus $36.49. All you have to do here is, 1, make sure that your planets line up, just like in Hercules. And 2, that you regroup as necessary. Since we're dealing with a bunch of zeros and the numbers are not zero underneath, we're going to have to regroup all the way to the last place value there. And then subtract as we normally would. For 19, we have 48 times 36. So 2 ways to solve this. You can do this using the standard algorithm, which again is 48 times 36 cents. Or we can use the box method that we went over earlier. So that's 40 and 8 and 30 and 6. And then all you have to do from there is multiply and add up all the pieces. So 4 times 8 is 6 times 8 is 48. 30 times 8 is 240. Complete the other 2 sets of operations and then find the sum of all four. Finally, for 20, it's just a matter of multiplying. 5 times 6 times 7. I always like to multiply by my 5s first, so that's why I'm not really going to change the order here. It's just going to be 5 times 6, and then the product of that will be multiplied by 7. That's going to give you your product. So this has been your homework help for today. For extra credit, something that we alluded to earlier in class, as growing children, we will soon be leaving some childish things behind, not all childish things. So extra credit will just be your favorite cartoon, either growing up or that you're still watching. One of my favorite cartoons at the moment that I was watching was She-Ra. I started watching it with my daughter, and then I ended up really enjoying it myself. So that is one cartoon that I was a huge fan of presently. If you ask me about my back in the day cartoons, the Spider-Man series, which is on Netflix, the X-Men series, also on Netflix, Yu-Gi-Oh! Pokemon, things that I watched even after I left behind my childhood years. So just your favorite cartoon, either now or all time. There are still some pretty decent ones out there. PJ Masks is actually pretty funny from time to time. I enjoy it. I'm not going to lie to you. My daughter also watches Miraculous Ladybug, which is also on Netflix. She's a big fan of that. Arthur, Cyber Chase, all the classics, big fans of those. Sesame Street is not a cartoon, but they did come out with this movie called When You Wish Upon a Pickle, which was absolutely hilarious, and I was definitely a big fan of. So anyway, extra credit, write down your favorite cartoon, either now or from years past. And that is your homework for today. So if you have any other questions, drop them in the questions thread or send me an email, and we'll see you tomorrow.